in my YouTube video channel of Engineering Graphics and Design subject. Myself Aarti Patel from LJ Institute of Engineering and Technology. This is 7th session of Engineering Curves chapter. In this session, we are going to learn cycloidal curves, which are cycloid, inferior trochoid and superior trochoid. Let us start with cycloid curve. What is cycloid curve? It is a locus of point on the circumference of rolling circle or generating circle which roll without slipping or sliding along a fixed straight line, or it's called director. Here you can see cycloidal curve generated by point on rolling circle which roll without slipping or sliding along a fixed straight line or director. Now the length of director is equal to 2 pi r or pi d, which is circumference area of rolling circle. Cycloidal curve are used in design of gear tooth profiles. Here you can see shape of gear tooth profile and a pair of gear. Next, let us solve example of cycloid curve. A wheel or circle of the diameter 50 mm rolls over the straight line for one rotation. Draw the path traced by the point P, which is initially at the point of the contact between wheel and the straight line. Draw normal and tangent at any point on the curve. First, list out given data. Diameter of wheel or circle is given 50 mm. So, radius R is equal to 25 mm. Length of director is equal to circumference area of rolling circle 2 pi r is equal to 2 into, put the value of pi is 3.14 into r 25 mm. So, the length of director is equal to 157 mm. First draw 25 mm radius rolling circle. Next draw director or straight line from bottom point of rolling circle. Take length of director is equal to 2 pi r is equal to 157 mm. Next, divide this rolling circle into equal 8 parts at 45-degree angle. Next, divide this director also into equal 8 parts. Mark here division points as 0, 1, 2, 3, 4, 5, 6, 7, 8. Here this rolling circle roll for one rotation in clockwise direction. So take division of rolling circle in anti-clockwise direction and mark here division points as 0, 1, 2, 3, 4, 5, 6, 7, 8. Next draw parallel to director line passing through 1 and 7 division point, 2 and 6 division point, 5 and 3 division points and 4th division points. Next draw perpendicular line from director division points up to this center line and mark here center points as C0, C1, C2, C3, C4, C5, C6, C7 and C8. Initial locus point of cycloid is at contact point of rolling circle and director. So locate here P0 point. Now for remaining locus point, take radius is equal to rolling circle, center C1 and cut arc on one number horizontal line. Similarly, take center C2, radius is equal to rolling circle and cut arc on 2 number horizontal line. Next, take center C3 and cut arc on 3 number horizontal line, C4 center and cut arc on 4 number horizontal line. Similarly, find out locus point of 5, 6 and 7 position of rolling circle. Mark locus point P1, P2, P3, P4, P5, P6, P7 and P8. Connect this all locus point freehandly in form of curve. Next, for normal tangent, select one point S on the curve anywhere. Take radius is equal to rolling circle, center S and cut arc on center line of rolling circle. Mark here T point. Draw perpendicular line from T point up to director and mark here S1 point. Connect S1 and S point, which is indicate normal. Next, draw perpendicular to normal line passing through S point tangent line. Next, let us understand inferior trochoid. Now, what is inferior trochoid? It is a locus of point inside the rolling circle or generator which roll without slipping or sliding along a straight line or director. Let us solve example of inferior trochoid. Draw locus of a point 20 mm away from the center of a circle which rolls on straight path. Take diameter of circle is 50 mm. First, list out given data. Diameter of circle or rolling circle is 50 mm. So, radius is equal to 25 mm. Length of director is equal to 2 pi r is equal to 2 into 3.14 into 25 mm radius is equal to 157 mm. Radius of inferior circle is given here 20 mm. So first draw 25 mm radius rolling circle. Next draw director AB from bottom point of rolling circle and take the length of director is equal to pi d or 2 pi r. Next draw inferior circle. Take the radius of inferior circle is equal to 20 mm. Now, in inferior trochoid, initial locus point is inside the circumference of rolling circle. So, locate initial locus point P0 on inferior circle. Next, divide inferior circle into equal 8 parts at 45-degree angle. Next, divide director AB into equal 8 parts and mark here equal parts points as 0, 1, 2, 3, 4, 5, 6, 7, 8. Here, rolling circle with inferior circle roll in clockwise direction. So, give division points on inferior circle in anti-clockwise direction. Next, draw parallel to director line from 0, 1, 7, 2, 6 and center 5, 3 and 4 points of inferior circle. Next, draw perpendicular line from division point of director up to center horizontal line and mark here center point of rolling circle C1, C2, C3, C4, C5, C6, C7 and C8. Next, for finding locus point, here take radius is equal to inferior circle, center C1 and cut arc on one number horizontal line. Next, take center C2, radius inferior circle and cut arc on 2 number horizontal line. Similarly, cut arc from C3, C4, C5, C6 and C7 center of rolling circle on particular number of straight line. Mark here locus point as P1, P2, P3, P4, P5, P6, P7 and P8. Join this all locus point freehandly in form of curve. So, this is the inferior trochoid. Next, let us understand superior trochoid. What is superior trochoid? It is a locus of point outside the rolling circle or generator which roll without slipping or sliding along a fixed straight line or director. Let us solve example of superior trochoid. Draw locus of a point 30 mm away from the center of a circle which roll on straight path. Take diameter of circle is 50 mm. First, list out given data. Diameter D is given 50 mm. So, radius R is equal to 25 mm. Length of director is equal to 2 pi R is equal to 157 mm. And radius of superior circle RS is equal to 30 mm. First, draw 25 mm radius rolling circle. Next, draw director from bottom point of rolling circle because rolling circle always roll on director. Next, draw superior circle. Take radius for superior circle is equal to 30 mm. Mark initial locus point P0 on superior circle. Next, divide superior circle into equal 8 parts at 45-degree angle. Next, director 2 pi R divide into equal 8 division and mark here division points 0 to 8. Here, rolling circle roll with superior circle in clockwise direction. So, mark division points on superior circle in anti-clockwise direction 0 to 8. Next, draw parallel to director line passing through all division points of superior circle. Next, draw perpendicular line from all division points of director up to center line of the rolling circle. Next, mark here center point of rolling circle C1, C2, C3, C4, C5, C6, C7 and C8. Now for finding locus point of superior trochoid, take radius is equal to superior circle is equal to 30 mm, center C1 and cut arc on one number straight line. Similarly, take center C2, radius is equal to superior circle and cut arc on 2 number horizontal line. Similarly, take center C3, C4, C5, C6 and C7 and cut arc on particular number horizontal line. Next, mark locus point P1, P2, P3, P4, P5, P6, P7 and P8. Join this all locus point freehandly in form of curve, so we will get superior droplet. So this is the end of this session. See you soon in next coming video lecture. Thank you.